Hey guys, ClassOfFour here, and today we're going to be looking at um, another another unit under algebra, and this is exponents and logarithms. So this is the first problem of many, and we'll go about to how to solve these type of problems and how to approach them. So let's go on and solve this problem here. So the problem at hand is solve log 2x plus log 2x minus 2 equals 3. And this is important. For x is greater than 2. That means that the x value has to be greater than 2. Alright, so now that we have this information, we might as well just rewrite the problem in a larger font so it's easier to read for us. Alright, x minus 2 equals 3. Alright, so now that we have this equation, what we have to do is simplify so we can get so it's easier to see the equation and solve for x, because in the end what we're trying to do is find out what x is equal to, so that when we put x into this equation and evaluate the left side, we will get the number 3. So let's go ahead and do this. Now, a log rule that you guys should be familiar of is, if we have, so this is a log rule and we're going to use this rule. The rule is, if you have log of b of x plus log of b, notice that the subscript is the exact same of a. Well, this is just going to equal log of b of x times a. So we can simplify two log expressions with which have the same base, and we simply multiply the a and the x together, so we get log of b is of x times a, and these are the exact same. So we're going to apply this to the left side of the equation, and we're going to get log 2 of x times x minus 2, and this is going to equal 3. Perfect. Now that we have this, we can simplify the inside, and so we will get log 2 of x squared, because I'm foiling, I'm just expanding out and multiplying x by each term inside it, minus 2x equals 3. Now that we have this expression, we will use another log rule that you guys should know, because I am assuming that you have some prior knowledge to logarithms and exponents. So the exponent, or the rule that we will be using, is if you have an expression like log a b, this is gonna equal x. So if you have an expression like this, what you can do is you can convert that expression to a to the x equals b. So knowing that that we can convert this expression to this expression, we will use that on this formula that we have simplified, and let's do that right here. So now that we're going to convert it to this. So first of all, our base is going to be a, which is our base here, so it's going to be 2 to the x, which is what it's equal to, so it's going to equal 3. So 2 to the 3, and then it's going to equal b, and in this case our b is our simplified expression right here, which is going to equal x squared minus 2x. Well, 2 to the 3 is really just 8, because it's 2 times 2 times 2, and that's just equal to 8. And that means that 8 is going to equal x squared minus 2x. Then we're going to simply bring the 8 to the other side of the equation and go 0 equals x squared minus 2x minus 8. Now we have a quadratic equation here. So how do we go about to solving a quadratic equation? Well, there are multiple ways we can do this, but I will go through the method of factoring. So the coefficient of the 8 term is 1, so it's just going to equal negative 8. And some and two numbers that multiply to negative 8 are gonna have to add up to negative 2. So to do that, well, I know that there's negative 4 and 2. So negative 4 times 2 is equal to negative 8, and negative 4 plus 2 is equal to negative 2. So we're going to factor it and go x squared plus 2x minus 4x minus 8. Now, this is the exact same thing. These two are the exact same equations. I haven't changed it at all. And that's because if we just simplify 2x minus 4x, well, we just get 2x. So I just expanded this negative 2 to make it a bit more complex by making it into two expressions. Now we will go around to factor it. So we're gonna factor this pair and we'll factor this pair. So a common factor of this is x. So we're gonna take x out of both terms and simplify, or factor rather. So I'll have x plus 2. And this, well, a common factor here is negative 4. So I will take negative 4 out of both terms, and we will also get x plus 2. Now that we have this, we can simplify or factor this even further. So we have x minus 4 and x plus 2. Well, there we go. Now that this equation is factored, it's very easy to solve. So we know that x minus 4 is gonna equal 0, or x plus 2 is gonna equal 0. Why is this? Because we're multiplying two numbers together, and whenever you multiply one number by 0, it automatically becomes 0. So either of these brackets is gonna have to equal 0, and we can solve it like this. So in this case, x is equal to 4, and in this case, x is equal to negative 2, because negative 2 plus 2 is 0, and 4 minus 4 is 0. Now, if you look back to the demands of the question, we see that we're asking for a number that is greater than 2. And this indicates that this is the answer. X is equal to 4. So x is equal to 4 is your answer. Now we'll move on to the next question. And of course, if you have any questions about what I did here, and if you have any confusions, feel free to drop a comment. Thank you. Hey guys, so now that we have finished the first question, let's go over a more simplistic question, which requires us to use simple log rules. And so yeah, let's go through them. First one, A. So it's let's look at the question first. Given that P is equal to log A5 and Q is equal to log A2, express the following in terms of P and Q. Okay. Or sorry, P and or Q. So A, the term is log A10. Now, we have information that our P is equal to log A5 and Q is equal to log A2. Now, we have to be aware that these log rules are only useful when the base for each log is the exact same. And that's why all the questions have the same base, A, A. So, the log rule that we will use for this is the addition log rule. And this rule, as was mentioned in the previous question, is log A B plus log AC is going to equal to log A B B times C. So let's use this formula, and we have information that of what P and Q is equal to. Now we know that 5 times 2 is equal to 10. So logically speaking, we just have to add these two expressions together. So we'll go ahead and do that. So log A10 is going to equal log A5 plus log A2. Now that we have the equation correct, we still aren't done with the question. And we're not done because it's asking us to express the following in terms of P and or Q. So there's no P and or Q here. So what we have to do is substitute these values for their respective variables. And to do that, we quite simply just substitute. So log A10 is going to equal P plus Q. And that's our answer, P plus Q. Now let's go on to B. So let's write B here. And the expression that we want is log A of 10 or log A of 8. Is it 8? Yes, it's 8. So log A of 8. So for this, we are going to use another rule, which is the exponent rule with logarithms. So this rule is as follows. If we have a coefficient in front of a log, sorry, let's not make it A because that'll just be confusing. Let's do D. Coefficient D with log AC. Well, this is going to equal log AC to the power of D. Okay? So, if I were to have 4 log, excuse me, let's turn this down a bit. Okay, log A of 2. Well, this is going to equal log A of 2 to the 4. And this is going to equal 16. So it's going to be equal to log A of 16. So now that we have this rule, we're going to use it for this. So we know that in exponent wise, we cannot get to 8 from 5. However, we can get to 8 by putting 2 to a certain power. And this is 2 to the 3. So log A8 is going to equal log A2 to some power. And we know that 2 times 2 times 2 is equal to 8. So therefore, 3 is the exponent that we're going to put, because 2 to the 3 is 8. Now, we have to, using this rule that we just learned here, we're going to move the exponent to a coefficient. And this is because at the current state of the equation, we cannot substitute in P or Q because the answer is looking for the expression in terms of the variable. So let's go ahead and do that. Log a and to the 8 is going to equal 3 log a2. Perfect. Now that we have this, we're going to substitute log a2 as q. So log a8 is equal to 3q. And that's our answer. Now let's move on to the last question of this problem, which is log a 2.5. So let's write down the question, log a 2.5. And we're going to use another rule here, which is when you're negating logs. So here is the rule. When you have log a x minus log a y, this is going to equal log a x over y. And that's the rule. It's quite simple, actually. So let's see how can we get 2.5? Well, when we see the available formulas or expressions that we have, we know that 5 divided by 2 is 2.5. So therefore, log a5 minus log a2 is going to equal log a 2.5. So I will write that down. Log a 2.5 is equal to log a5 minus log a2. But we aren't done yet, and this is because we have to substitute and make sure that our expression, our answer, is in terms of p and q. So let's go ahead and do this. So log a 2.5 is gonna equal p minus q. And that's correct. So the big idea or lesson here of this question was to know your log rules and to understand the demands of the question, because many people would just stop here at this step. And this is correct, but it's not correct in terms of what the question is asking, which is to express your answer in terms of what it's at, in terms of the variables that you have to substitute for. So if you have any more questions on log rules, feel free and ask me. But now we'll move on to the third question. And yeah. Hey guys, so now we will go on to the third question in this video, and this deals with the topic of exponents. So let's take a break from logarithms and let's get on to exponents. So this is the question. Solve the equation 9 to the x minus 1 equals 1 over 3 to the power of 2 over x. So what we have to do in this question is find what x is equal to. What number does x equal? And with this, we will be able to solve and give the answer. So I will just rewrite the question, or formula rather, here. And now let's see what we have. So we have 9 to the x minus 1 equals 1 over 3 to the power of 2 times x. So here we will use an exponent law, and this rule states that if we have, okay, so let me try to explain this. If we have a number, for example a squared, and this is to the power of x, and this is equal to, let's say, a to the power of 5x. Well, what we can do is, what we have to do is we can go and say that a to the 2x, because we multiply when we're expanding here, so we have just one term. We have a to the 2x equals a to the 5x. Now we can see that okay, so the exponent rule here is that we can cancel if the base is the same. So you have 2x is equal to 5x. Now this equation doesn't really make sense, but the idea is that when you have a term and this has to be the base only, and the base is the same on both sides of the equation, you can cancel out the base and you will be given left with the exponent equaling the other exponent. So using this rule, hopefully I made that a bit clear, we'll just use that rule over here. So we what's the square root of 9? That's just 3. So 9 is the exact same as 3 to the power of 2, and then following along x to the power of 1. And this is equal to, now we have to make the bases the same in order to cancel them out. So we will have to flip 1 over 3 to 3 over 1. So it's just 3. And this is going to be to the power of negative 1. And following along to the power of 2x. Now let me explain what I did here. So 3 to the negative 1 is just simply finding the reciprocal of this number. So 3 to the negative 1 is going to equal 1 over 3. And another example of this is, let's say you have 1 over ten to the power of 1 to the power of negative 1. And this is just going to equal 10. So we will go, and now we have to simplify and multiply the inner exponent with the outer exponent, so we get rid of these brackets, because quite frankly they look quite ugly in the equation. So this is going to equal 3 to the 2 times x minus 1 equals 3 to the negative 1 times 2x. Moving along, we can simplify the exponents to 3 to the 2x minus 2 equals 3 to the negative 2x. So now that we have this, we can use the rule that we learned here, right here. We can just cancel out the bases, so we're left out with the exponents. So we cancel the bases out because they're the exact same and there's no other terms in the equation. And we will be left with 2x minus 2 equals negative 2x. Now that we have this, we can easily use algebra and solve for what x is equal to. So let's go ahead and do that. So negative 2 is going to equal negative 2x minus 2x. Negative 2 is going to equal negative 4x. And then we will go ahead and go negative 2 over negative 4, which equals x, and this concludes to x being equivalent to 1 over 2. And that's our answer for this equation. X is equal to 1 over 2 or 0.5, because they're the same thing. Thank you for listening in, and we will now move on to the third question. This is the third question. We'll move on to the next question now, and I'll see you there. Hey guys, so now we are going to go for, this is the last question by the way in this video, and this is one of the more challenging questions that you may face, and this not only involves logarithms, it involves functions as well. Knowledge on functions. So let's go on to the first question, A. So first of all, the question gives us some information here. It says let f of x equal k log 2x. So this is our function. And A is asking, given that f of negative 1 of 1 equals 8, find the value of k. So we know that f of negative 1 of 1 is equal to 8. And with this knowledge, we can then find out that f of 8 is equal to 1. And I know this because this inverse function, we can invert the solutions or the x or the coordinates to find out what the coordinates are for the regular function. So now that we have this information, and we know that f of x is equal to k log 2x, we'll substitute, and except for x, we will substitute 8 into x. So I'll just go ahead and do that to show exactly what I'm doing. K log 2 of 8 is going to equal 1. So I knew f of x is k log 2x, but since it's f of 8, I'm going to input 8 into that x. So now that we have this, we're going to simplify and find out what k is, because the question is asking what is the value of k. So this expression, I feel, can be simplified much further so that it's just simple algebra. So on the side here, we will go ahead and do this. So we have log 8. And previously in the video, I mentioned the rule where we could convert log a b equals x, and we can convert this to a to the x equals b. And in this case it equals x because it's going to equal some number that we're going to simplify to. So using this rule, we're going to see that 2 to the x is going to equal 8, and we know that x is going to equal 3 because 2 to the 3 is going to equal 8. So now that we have x is equal to 3, we're going to simply substitute this whole value for it. They're equivalent. Log 2 to the 8 is the exact same as 3. So that means k times 3 equals 1. Well, this just becomes a very simple arithmetic. It just requires very simple arithmetic. So that means that k is going to equal 1 over 3. There you go. That's our answer. K is equal to 1 over 3. Now let's look at b. b is saying to find f of negative 1 of 2 of 3. So let's go ahead and do that. F of negative 1 of 2 over 3 is going to equal y. Likewise, we're going to go ahead and go that f, the regular function of the inverse function of 2 of x, is going to equal 2 over 3. So there we go. Now what we have to do is substitute what f of x is equal to. And we know that f of x is going to equal to k log 2x. But we know what k is, so we're going to bring that over here. And we're going to go with 1 over 3 log 2x equals to 2 over 3. Great. Now what we're going to do is we're going to have to simplify this expression so we find out what x is, because that's the goal, to find what x is as a number. So we're going to go ahead and we're going to go log 2x, and this is going to equal 2 over 3 divided by 1 over 3. Now, one way I like to do this is when I'm dividing a number, when I'm dividing two fractions, it's the exact same. Whoa, what happened to my pen there? 2 over 3 times the reciprocal of the second fraction. So these are equal. And this is going to be equal to 6 over 3, which is just equal to 2. So now that we have that, we're going to see that log 2x is equal to 2. Now that we have this, what we have to do is simply solve for x. So now that we have this expression here, what we're going to do is we're going to use the log rule that we used previously to convert this. So as I said, log a b equals x. We can convert this to a to the x equals b. And in this case, when we convert it, this is going to equal 2 to the power of 2 equals x. And quite simply, 2 to the power of 2 is 4, so 4 is equal to x. And there is your answer. Now, if you have any questions or confusions regarding what I did here, or any if you want me to further discuss on certain concepts that I used, feel free to drop a comment, and thank you for watching. I hope you have a nice day.